There are many videos showing soap boats experimental like this. Add a drop of soap to a boat and it travels for some distance, and then stops. But we make a soap boat travel continuously on water. We prepared a plastic dish filled with water and a beaker to form a circular waterway. A plastic boat with a needle to wake the surfactant, and some dish soap which works as a surfactant. In the test, we can see the boat moves only slightly after adding dish soap. What's more, even if we add more soap, the boat does not continue moving. Let's understand why the boat moves and why it stops. Before adding the dish soap, the surface tension of the water atmosphere surface is the same everywhere, so the boat is being pulled equally from all directions. After adding the soap, the surface tension near the back one end of the boat decreases, so now the boat is being pulled less from its backside. This surface tension gradient is a Marangoni stress, and it drives the boat forward. But why does the boat stop? The same Marangoni stress spreads the soap all over the surface, including a hand of the boat. It also diffuses into the bulk water. Once the surface and bulk water become saturated, the surface tension will not change even adding more dish soap. So now the boat cannot move. Now that we know why the boat stops moving, it is obvious that to keep it moving, we must make the surfactant leave the surface. One way to do it is to select a volatile surfactant which can evaporate. Thus, the surfactant will not saturate the water-air surface and all the bulk water. We will maintain a Marangoni stress indefinitely and the boat will keep moving. Let's see if this works. We repeat the same experiment except the surfactant. Here, we will use two volatile surfactants, S-propanol and ethanol.
First, we drip 2 or 3 drops of isopropanol to the middle of the boat. The isopropanol wicks along the needle to the water-air surface. The Marangoni stress drives the boat flow instantly, but it does not stop. Then the boat travels continuously because the surfactant will evaporate into air, and the Marangoni stress can persist. After all the isopropanol fuel from the boat is exhausted, the boat stops. However, unlike the dish soap, we can add more isopropanol to drive the boat flow again due to the unsaturated water atmosphere surface. We follow the same procedure with ethanol to verify that the continuous travel is not because of any unique properties of isopropanol. After we drop the ethanol on the boat, it does the same thing. And once the boat stops, we can refill it with more ethanol and drive the boat flow again. Results directly answer the question at the beginning of the video. A soap boat can travel on the water surface indefinitely if we select the right kind of surfactant.